Good evening everyone. Welcome to Akshar IIT Foundation. This is Srinivas, your maths faculty. Welcome to today's class. Right. So before going to today's concept, let us see what we have discussed in that number system. So we discussed about the prime numbers, composite numbers, number of divisors, sum of divisors, product of divisors, right? And we have finished some problems in exercise 1. So let us continue the problems. Yeah, see here. Up to 11 questions we have completed. Now this is the 12th question. The number of natural numbers up to 150 that are divisible by 7. That are divisible by 7. Right. Up to 150 numbers divisible by 7. Simply, the number which are divisible by 7s are nothing but the numbers which are coming in the table of 7. Okay. Now, 150 is a smaller number we can identify easily. In case if it is very large number, how to do it? So simply we divide that number with the given 7. So here 150 should be divisible by 7. We know that 150 is not exactly divisible by 7. That up to 150, how many numbers are there? We have to identify that. Okay. Yeah. So simply 7 2s 14. 1 remainder. 7 1s are 7. We are not considering about the remainder. Up to then, there are 21 multiples of 7 up to 150 natural numbers. Okay. So our answer is 21. Because your question is asked from starting to 150 numbers. That means 1 to 150 numbers, there are 21 multiples of 7 are nothing but 21 numbers which are divisible by 7. Okay. So simply we do the division with the 7 table. Okay. So same question they may ask in different manner also. That means they can twist the question for getting instead of asking from 1 to 150 numbers, they may ask what are the numbers divisible by 7 between 20 and 150. They can ask like that also. Okay. Let us see that type of model also. We should look into it. Next, total number of factors. Number of factors we have learned that is, if any composite number can be expressed as product of primes. So 36 is a composite number. This can be expressed as product of prime numbers. And the prime factorization is also unique. We know that. Let us find the prime factors here. Now I am taking the first prime number, that is 2. 2 table 18 times, 2 18s are 36. Again 2 table 9 times. Now 2 table will not come in 9 table. Sorry. 2 table not having the 9. So we can take next prime number, that is 3. 3 3s are 9. And 3 1s are 3. So this 36 can be expressed as 2 into 2 into 3 into 3. That is nothing but 2 square into 3 square. And we know the formula that if any number is in the form of p1 power n1 into p2 power n2 into and so on, where p1, p2 are prime numbers and n1, n2 are their exponents. So same way 36 can be written as 2 power 2 into 3 power 3, where 2 and 3 are prime numbers and their exponents. 2 exponent is 2 as well. 3 exponent is also 2. For this type of, if a number is in the form of n equals to p1 power n1 into p2 power n2 like that, number of divisors formula is n1 plus 1 into n2 plus 1 and so on, where n1 and n2 are exponents of prime numbers respectively. So let us find it. Divisors of, what is the number for us? 36. And its exponent, what is the first exponent? 2. 2 plus 1 into, second exponent is also 2. Yeah, 2 plus 1 is 3. Here also 3. 3 into 3, 9. Therefore, total number of factors for 36 is 9. So, our answer is obviously 9. Got it? Okay. So, 36 is a very small number. We can directly find its factors also without using the formula. Like one table, two table. Every table we have to check and how many number of factors are there. We can count easily because 36 is the smallest number. That means just a 2-digit number, no? In case 3-digit, 4-digit, 5-digit. In that case, we can use this method, will be very useful for us. Coming to the next question. The number of odd factors of 90. Same here also, like in our previous problem, here also we have found that number of factors, but here not mentioned about odd numbers and even numbers. That means in the factors which if they are odd numbers, we are considering as odd factors. If you take even number, they are considering as even factors. Okay. So simply while I am explaining here, 36 can be written as 2 power 2 into 3 power 2. That means 2 is even prime number, 3 is odd prime number. If asking about the odd prime numbers, we should asking about the odd factors, we should only take odd primes. That means in this case we have to take only 3 power 2 or 3 square. Clear? Let us see for this problem. 90 is a number. Let me convert this 90 as product of prime numbers. So 2 table, 2 45s. Next I can take 5 table directly. 5 9s 45. 3 table, 3 3s, 3 1s. So this composite number 90 can be expressed as 2 into 3 square into 5. 2 into 3 square into 5. Among them, what are the odd prime numbers? We learned already we have only one even prime, that is 2, remaining all odd primes only. Now you are observing here, there are 2 odd numbers I can identify here. One is 3 and second one is 5. So number of odd factors, equals to, now let us consider only odd primes. First odd prime is 3 and the second odd prime is 5. So its exponent 2, 2 plus 1 and 5 cannot appear any exponent, that is nothing but 1. That is 1 plus 1. So 2 plus 1 is 3 into 1 plus 1 is 2, nothing but 3 2s are 6 odd primes. So our option is obviously 2. Clear, children? Just we found the prime factors of a composite number and we just choosing only odd powers. We are just choosing only odd prime numbers and their exponents. Okay. Coming to the next question. The number of numbers between 11 and 111 which are multiples of both 2 and 5. Now, if the question is asked multiples of 2, according to the previous problem, we just divide the given number with 2. but you are asking that which are multiples of both 2 and 5. Now you are observing that 2 and 5 both are prime numbers. They are coming, both the numbers are coming only the multiples of 10. 2 5s are 10. So instead of checking both 2 factors and 5 factors, we can check only the factors of 10. Now among 11 and 111, what is the highest number? 111. So let us find how many numbers which are divisible by both 2 and 5 up to 111. That means I am considering from number 1 starting onwards. That means natural number 1, 2, 3, 4, 5. All numbers I am concluding. I am taking. Okay. Up to 111. So same like previous problem. 10 table, 10 tens 100, 10 11s 110, here remainder 1. So from 1 to 100, from 1 to 111, there are 11 numbers which are divisible by both 2 and 5. Okay, but we don't want from 1 to 111. We want from 11 to 111. So now I am going to check how many numbers are divisible by both 2 and 5 up to 11. That means 1 to 11, how many are there? So simply I am dividing 11 with 10. 10 ones are 10. That means from 1 to 11, only one number which is divisible by both 2 and 5. So there is only one number. But we don't want from 1 to 111. We want only 11 to 111. So 1 to 111 we got 11 numbers, and 1 to 11 we got 1. So I am removing this one. So 11 minus 1 is nothing but 10. So from 11 to 111, there are 10 numbers which are divisible by both 2 and 5. So our option is 1. Okay, children. So I am doing the division 2 times because we are not asking about from 1 to 111. We are asking about 11 to 111. So first I found total numbers between 1 to 111. Then I remove from 1 to 11. Okay? Is it clear? Right. Coming to the next question. See here, the minimum value of this expression, modulus of 17x minus 8 minus 9 is, here given modulus of 17x minus 8 minus 9. Now we have already discussed that modulus of a, this type of numbers, a can be any integer. If the a can be, keep it in the place of modulus, we are calling that number is absolute value. What is that? Absolute value. We already discussed that if a can be any integer, whether it is a positive or negative, I am taking both the conditions. If a value is positive, then absolute value of a is positive a, where a greater than 0. And second case, if a value is negative, that means absolute value of a is minus a, where a value is less than 0. A value is less than 0. Okay, na? This is what is absolute value. Clear until then? Now, the minimum value we need to find for this expression. Before going to that, if you identify that absolute value of any number gives always positive value only. Absolute value of any number gives always positive value only. Now I am checking that each and every option while substituting in this expression. Now see that first question. First option is 0. Now I am substituting 0 in the place of x. Now it will be 17x is nothing but 17 into x. So 17 into 0 minus 8 minus 9. So 17 into 0 is 0. 0 minus 8 is negative 8. So whenever an integer is in the modulus, we are considering that value gives positive. Here 8 minus 9. Therefore the answer is minus 1. Okay. From the first option, if we substitute the value 0, we will get the answer is negative 1. Now let us check it for second option, 8 by 17. So 17x, in the place of x I can write 8 by 17 minus 8 minus 9. Numerator 17, denominator 17 cancel. Still we got 8. 8 minus 8 is 0. So modulus of 0 is 0 only. We get only minus 9. Among these, which is smallest? Minus 9 is the smallest. Coming to the option 3. 17 into minus 9, minus 8 and minus 9. Right. What is the value of 17 nines are 161. But 17 is a positive number, 9 is a negative number. Plus into minus gives minus. Here minus 8. So in the modulus symbol, we got both of the values are negative. We can add with the negative symbol, and it is 161. Yeah. Minus 161 and minus 8 becomes minus 169. In modulus it will be plus 169 minus 9. It is positive 160. Still, among these three options, we got the less value is modulus of 9. Now coming to the last option, 17 ones are 17. 17 minus 8 minus 9. So 17 minus 8, how much? 9. 9 minus 9, 0. So among the four options, we will have the smallest option is minus 9, and it will come when the modulus value becomes 0. Okay, na? The smallest value, to get the smallest value, the modulus value should be 0, then we are getting the smallest value. Okay, right. Option is 8 by 17. Clear, children? Right. Coming to next question. This is same like previous one. How many numbers divisible by 11 to 111? Same like that. See this model. What is the larger among these? 666 and smaller one 333. See the question. The number of numbers between 333 and 666 are divisible by 5. That means how many multiples of 5 are there in between 333 and 666. Okay. Now let us find the largest number. Now I have to find total numbers between 1 and 666. Starting from 1 I am taking natural numbers, all natural numbers. From 1 to 666, how many divisibles are there we have to find. Then we remove up to 333. Okay. Yeah. 5 ones 5. 6 down. 5 3 is 15. 1 remainder. Again 6 down. 5 3s 15. So there are 133 numbers which are divisible by 5 from 1 to 666. That's what I am writing. From 1 to 666, there are 133 numbers. Okay. Now from 1 to 333. Now just I am doing division. 5 table again. 5 6 are 30. 3 remainder 3 down. Again 5 6 are 30. We are leaving the remainder. The quotient is 66. So from 1 to 333, how many are there? 66 are there. Okay, na? But I want only the between numbers from 333 to 666. Now I am going to subtract both of them. So our required answer is how much? Oh, 67. That is nothing but option 3. Okay, na? Only numbers which are divisible by 5 between 333 and 666. Okay. Coming to the next question, 18th question. 2a minus 9, I am writing the expression 2a minus 9 is equals to b plus a. It is an equation. So this equation, then the value of this, we need to find out the value of that. Okay. Now before that, let me find any clue from this equation or not. Now from this, I am just taking all the variables one side and all the numbers one side. Here 2a is a variable. Here b plus a, both are variables only. Both are letters. I am bringing this side. Plus b becomes minus b and plus a becomes minus a. So I can write this one minus a minus b. Now this one I am transposing here. That means minus 9 is a constant. I am transposing that side. It will be plus 9. Now see here 2a minus a. 2a minus a value how much? Very good. 2a minus a value is a. Minus b equal to 9. So we got the value of a minus b. Okay. Now let us take the required answer. We need to find the answer for this. So modulus of a minus b plus b minus a. Let us simplify this. Without the brackets, it will be a minus b plus b minus a. See here, plus a minus a is cancelled. Plus b minus b also cancelled. Got the answer 0. Without finding the answer, we got it 0. That means we no need to solve from this given equation. Okay, na? Or you can let us try in another way also, or anything is right. Okay, na? Yeah. Once here, look at here. From this given equation, if you wanted to use this equation, from these two equations also we will get that. From this answer also we will get the same answer. Okay. Let us see how it get. A minus b value minus 9. What about b minus a value? A minus b value is positive 9, means b minus a value negative 9. Now directly we can substitute here. In the place of a minus b, we can write positive 9, plus in the place of b minus a, we should write negative 9. So anyways, we will get the same answer 0. Okay? Because we already found the value of a minus b, no? With the help of substituting the values also, we will get the same answer. Right. Coming to the next. Now, product of divisors. We have discussed in our previous class, product of divisors formula is the number power number of divisors by 2. This is the formula we should use to find the product of divisors. Now here asking about 7056. Before that, for finding sum of divisors, number of divisors or product of divisors, first we should find how many number of divisors are there by using the prime factorization method. Okay, now let us find it. Yeah, I am taking two tables because the 7056 is ending with even number. Okay, so 2 35s are 70, 2 2s 4, 2 8s are 16. Again 2 table, 2 1s, 2 7s, 2 6 and 2 4s. 2 8s are 16, again 2 8s are 16, 2 2s. 441, and this 441 is coming in 3 table also because it is ending with odd number and we cannot take 2. But let us check it is coming in 3 table or not. What is the divisibility rule for 3? Sum of its digits must be multiple of 3. Now check that digits. 4, 4 plus 4, 8, 8 plus 1, 9. 9 is a multiple of 3. So we can take 3 table. 3 1s, 3 4s 12, 3 7s. Now 147 will come in the table of 7. So we can take 7 table, 7 21s, again 7 3s, 3 1s. So 7056, the number can be expressed as product of primes. While you are observing, there are 3 different type of prime numbers, 2, 3, 7. Okay, 2 how many times? 2 is presenting here 4 times. Now I can write as 2 power 4. Now 3 how many times? 3 is presenting 2 times. So we can write 3 square. Now another prime number 7. 7 is presenting 2 times. It is 7 square. Now number of divisors, by taking n1 plus 1 into n2 plus 1 into n3 plus 1. This is the formula, and n1, n2, n3 are exponents of prime numbers respectively. Now first prime number 2, its exponent is 4, so we should write 4 plus 1. Now second prime number is 3, its exponent is 2, 2 plus 1, and last one also 2 plus 1. So 4 plus 1, 5 into 3 into 3. How much? 5 3 is 15, 15 3 is 45. Now let us substitute here. Here n is nothing but the number. N is nothing but the given number. Okay? Yeah. What is the given number? 7056. Whole power number of divisors by 2. Number of divisors we got 45. 45 by 2. Now check the answers. Check all the options. All are in the powers of 84 power, 84 power 44, 84 power 45. All are powers of 84. So we have to identify that 7056 is nothing but 84 84s. Let us check. Now 4 4s are 16. 1 32 plus 1 33. 8 table 32. 3 carrying 64 67. Yes. So 84 are 7056. We can write this 7056 as 84 into 84, nothing but 84 square, power 45 by 2. Now it is in the form of a power m whole power n. Laws of exponents, you learn that a power m whole power n is nothing but a power m into n. We applied here 84 power 2 into 45 by 2. So numerator to denominator to cancel. So we have remains only 45. It is nothing but 84 power 45. Okay? This is the process we should follow. Next. The number of ways of 576 can be expressed. This is very, very important. So now let us see that the number of ways to express a composite number as product of its factors. Product of two factors or product of two distinct factors. So number of ways for product of factors formula is number of divisors plus 1 by 2, and product of two distinct factors. Two distinct factors means number of divisors minus 1 by 2. So among these two formulas, we should use the formula for number of ways to express a number into product of two distinct factors is number of divisors minus 1 whole divided by 2. Now let us find the number of divisors for 576. Yeah, 2 table here because it is a even number. So 2 2s, 2 8s, 2 8s. Again 2 table 144 times. Now 2 table 72 and 2 table 36, 2 table 18 times. You need to calculate quick. 2 9s, 3 3s, 3 1s. So 576 can be expressed as product of its prime factors. Here I can see two different prime numbers. One is 2 and another one is 3. How many times 2 is presenting? 1, 2, 3, 4, 5, 6 times. So we can write 2 power 6. And 3, how many times it is presenting? Here 2 times 3 square. So number of divisors is 6 plus 1 into 2 plus 1. Like formula n plus 1 into n plus 2, where n1 and n2 are respectively the exponents of prime numbers. Now 7 3 is 21 numbers. So number of distinct ways of expressing two factors, product of two factors is number of factors is 21 minus 1 by 2. 21 minus 1 is 20, 20 by 2 10. Okay children? Now, the sum of three prime numbers, very, very important problem. Sum of three prime numbers is 100 if one of them is exceeds the another by 36. It is very, very important. Let us check three prime numbers. Sum of three prime numbers 100. So we don't know the prime numbers. So prime number 1 plus prime number 2 plus prime number 3 equals to 100, and one of them exceeds another by 36. Among them, one of them exceeds. One of them I am taking x, another one of them exceeds another by 36. If you take one of them x, then another one will be x plus 36. So x is one prime number, x plus 36 is another prime number, and third prime number we don't know. Let us take it as y. We don't know the third prime number. So let us simplify. X plus x 2x, 2x plus 36 plus y equals to 100, plus 36 transpose that side, it will be minus 36. Here the variables are 2x plus y equals to 100 minus 36. 100 minus 36 how much? Very good. It is 64. 100 minus 36 is 64. Okay. Now, according to the given concept, if three numbers sum is 100, if you check that sum of two odd numbers is odd number, sum of two odd numbers is even. Okay. If you take three odd numbers together, then what we will get? First two odd numbers, if you add, you will get answer even number, and even number plus odd number will give you odd number. Even plus odd will give you odd number. That means it is 100, it is not odd number, it is even number. That means from these three numbers, one must be even number. From these three numbers, one must be even number. What is the chance of getting even number for these three prime numbers? Let us check for x. If x is even prime number 2, then another one is 2 plus 36. 2 plus 36 is 38. 38 is not a prime number. So the only chance of getting even prime number is y. Y is having the chance of getting even prime number. Now in the place of y, I am substituting even prime number 2. Then 2x value is 62, and x value is 62 by 2 is 31. If you got x value is 31, then x plus 36, 31 plus 36 is 67, and y value is 2. So simplify, you can write 2, 31, 67. These are the combination of three prime numbers. So let us check the answers. So we don't have option 2 here. 31 also not have, only 67. This is our required answer. Okay, children? So this is very, very important and fundamental concept here. Yeah, that's it for today. Thank you, one and all. Have a nice day.